Fascinating Frontiers, episode 114. It's June 27th, 2026. Here's what's happening in space and science today. Mars is gliding past the Pleiades star cluster in the early morning sky, offering a rare close pairing visible before sunrise. Mars currently sits in Taurus and appears in the pre-dawn sky. Today it lies less than 5 degrees from the famous Pleiades star cluster designated M45. Observers who rise early can spot the pairing low in the east before sunrise washes it out. The geometry places Mars on a line of sight that brings it unusually near the cluster's bright stars from our viewpoint. Watch for the pair to separate gradually over the next several mornings as Mars continues its eastward motion. On a completely different note, a sizable asteroid is set to pass Earth this weekend. The object draws attention from observers around the world. It is large enough to be monitored by both professional and amateur telescopes. This flyby will help refine orbital predictions for the asteroid. At the same time, the event allows teams to test their detection networks. Anyone interested can find details in regular space weather updates. Viewing guidance is also provided through those same updates. While we track objects passing Earth, researchers are tracking what our own hardware leaves behind on the way down. Rocket re-entry events leave measurable metal traces in the upper atmosphere. Researchers have linked specific re-entry events to sudden spikes in atmospheric metal concentrations. The data come from ground-based sampling that captured elevated levels of elements commonly used in spacecraft construction. These measurements show how material from returning stages disperses at altitudes where it can interact with the stratosphere. Follow-up studies aim to quantify how frequently such injections occur as launch rates rise. That atmospheric finding gains extra clarity when we look at orbit itself from a new perspective. A satellite tracking tool now includes an option that removes artificial magnification, so objects appear at their real sizes. Users can select the International Space Station and watch the view zoom out until the station shrinks to a single pixel against the globe. The update incorporates accurate three-dimensional models for the International Space Station, Hubble, Tiangong, and thousands of Starlink satellites. Real-time propagation still runs on Celestrack data, but the visual now matches the physical spacing of objects in orbit. Even the crowded shells of Starlink satellites become widely separated points against the planet's curve. The same view shows why collision warnings remain rare despite thousands of objects. One open question is how future mega constellations will alter that spacing once every orbital shell fills to higher densities. The loudest gravitational wave signal yet helps probe black hole event horizons. The detection supplies new data on the boundary beyond which nothing escapes a black hole's gravity. Analysts examined the waveform's fine structure to extract information about space-time geometry right at the horizon. Continued observations of similar loud events could tighten constraints on how matter and energy behave in these extreme regions. Extreme physics at the edge of black holes contrasts with the practical engineering of getting humans back to the moon. Lawmakers have introduced legislation to honor the 4 astronauts selected for the first crewed flight of the Orion spacecraft. The medal would recognize the mission's role in returning humans to the vicinity of the moon. If approved, it would join a short list of spaceflight achievements recognized at this level. Policy recognition for the crew pairs naturally with the hardware that will support them on the surface. NASA selected providers to build iterative versions of earlier lunar rover concepts. The goal is to deliver operational rovers ahead of the Artemis 4 crew arrival, so astronauts have mobility from the start of surface operations. The contracts emphasize reduced development time and lower costs compared with previous vehicle programs. Surface mobility depends on another key technology now moving from test to flight hardware. Engineers evaluated a prototype nozzle and receiver system designed to transfer propellants between spacecraft. The hardware must maintain seals at extremely low temperatures while allowing rapid connection and disconnection. Successful tests moved the technology closer to demonstrations that could support longer deep space missions. Refueling tech helps long-duration missions. Another NASA program is already gathering the atmospheric data those missions will need. The BALL-NEO project will fly a balloon network to sample stratospheric aerosols. The initiative aims to gather regular, in situ measurements of particles that influence global temperatures and the water cycle. Multiple balloon platforms will operate at different longitudes to capture variability that satellites see only intermittently. Data will feed into climate models that currently rely heavily on remote sensing averages. While balloons study our own atmosphere, Hubble has been examining stellar birth in an ancient cluster. Hubble images an ancient globular cluster showing two distinct star formation episodes. The cluster contains tens of thousands to millions of stars packed under mutual gravity. Observations reveal one population of stars that formed early and a second group that appeared later, suggesting the cluster experienced separate bursts of star birth. More than 150 such clusters are known in the Milky Way, though others may remain hidden behind dust. Understanding stellar history feeds into student work on keeping future crews alive. University teams win NASA's 2026 Human Lander Challenge for life support concepts. Student groups presented environmental control and life support designs intended for future crewed lunar landers. The winning entries addressed air revitalization, water recovery, and thermal management under lunar gravity conditions. The competition feeds directly into technology development supporting the Artemis program. Student ideas for life support connect to a 2024 geomagnetic storm that rewrote assumptions about Earth's own atmosphere. Measurements showed that the intense event drew ions primarily from the planet rather than the solar wind. The finding revises earlier assumptions about how ring current populations are replenished during major storms. Continued monitoring will test whether this source dominance holds for future events. Atmospheric surprises above Earth lead to an upcoming attempt to raise an observatory's orbit. The Pegasus rocket is prepared to launch an orbit-raising spacecraft for the Swift Observatory. The mission targets a no earlier than June 30th liftoff from Kwajalein Atoll. The small upper stage vehicle will dock with the aging Neil Gehrels Swift Observatory and gradually increase its altitude over several months. The effort marks the first attempt to extend an operational astrophysics mission through in-space propulsion assistance. Extending existing missions sits alongside a new PBS documentary looking at the next era of lunar exploration. Season 53, Episode 7 of the long-running science series focuses on current lunar exploration architecture. The program covers lander development, surface operations, and the role of commercial partners in establishing a presence. Interviews highlight engineering challenges that must be solved before crews can stay for extended periods. Media coverage of lunar plans follows a company already building the ground infrastructure for rapid rocket reuse. Site visits more than 6 months ago showed substantial progress on infrastructure needed for full rocket reuse. The company continues work on a vehicle designed for rapid turnaround between flights. Observers are watching for the next visible milestones in testing and assembly. From one company's rapid reuse ambitions to a quiet but telling update on how empty low Earth orbit really is. A single large stage can inject kilograms of aluminum, titanium, and iron compounds directly into the mesosphere during its fiery passage. Those atoms then drift downward over weeks or months, mixing into the aerosol layer that influences both ozone chemistry and the planet's radiation balance. If every re-entering rocket stage were compressed into a single layer, the metal it releases would form a film only a few atoms thick, spread across the entire stratosphere. Yet that tiny addition occurs at altitudes where chemistry proceeds slowly and where natural sources of those same elements are scarce. No one yet knows whether the cumulative effect of rising launch rates will eventually rival volcanic or meteoritic contributions on a global scale. Next time, keep an eye on the Pegasus upper stage docking attempt scheduled for no earlier than June 30th. That's fascinating frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at Nara Network. Links in the show notes. And before you go, this show is part of the Nara Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Models and Agents for Beginners. Artificial Intelligence Explained Simply for Beginners and Curious Teens. Find every show free at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through